Okay, so following up from our review class, I had one more example that I wanted to do using the t-test. So here is the test, the example. So we have test of the computer component are finding that the mean time between failures is 520 hours. They make a modification because they want the computers to last longer. So they had a random sample of 10 components and found the times that are listed here for the time until failure. And we want to test at the 5% significance level. We want to test the claim that the mean time between failures has actually gotten better, that the modification that they made improved what was going on. So that's our problem. And the reason that this is a t-test instead of a z-test is because we haven't been given a population standard deviation. So we have to use t. So we'll start with A, the null and alternate hypotheses. So our A, the null hypothesis, is the boring thing that we are hoping to disprove, and that is that the mean has not changed. So the population mean is still 520 hours. So mu is still 520 hours. The alternate hypothesis, this is the thing that we are hoping will be true, is that, and it says that we want to test the claim that the mean time is greater than 520 hours. So we are doing a one-tailed test here. We want to say that the new mean is actually greater than 520 hours. For B, we were told that we were trying to do this test at the 5% significance level, so we want 95% confidence in our outcome, and that is an alpha value of 0.05. And for C, this will be a right-tailed test because we have this greater than sign. So anytime you see a greater than sign, it's a right-tailed test. So and to think about what the distribution is going to look like for this, we're going to have something that looks like this, and we're going to have a bunch of t's here, so our t equals 0 will be right there, and we are going to use the critical value method to see if the t-score that corresponds to this data here is in this number, this section of the curve right here. So if we find that the t-score that corresponds to our new data is in this chunk of the curve that corresponds to 5% of the area, then we'll be able to reject the null hypothesis and say that this modification has actually improved our computer lifetimes to within 95% confidence. So right over here is our rejection region. And this is a right-tailed test because the right tail of this distribution has our rejection region. A left-tailed test would be that we were shading in this area over here. So for question D, what's the value of the test statistic? I went ahead and printed off the equation sheets that we'll have for the test. So these are all right with the exception. So actually there is a typo on these two formulas that's been updated. So our t statistic is right here. So we want to do the t statistic is x minus x bar divided by the sample standard deviation. So we are going to compute the t statistic. So we have our our test here, which is 520 hours. So that's the thing that we're going to plug in for the population mean, but we need actually to have the mean of this data and also the sample standard deviation of this data. So to do that, we're going to put it in our calculator. So here's my calculator. So to put in a list in a calculator, I push the stat button right here, and that brings up this screen. I'm going to push edit, so just push enter. And I've already put in these 10 data points, so probably give it a pause and get that in. And when you come back, we will go and figure out the mean and standard deviation of this data. You can use the formula to do that, but it's much easier to use it in your calculator. So I put all 10 of the data points in here, and I guess I should show you the 10 data points so that you can do this as well. And then I'm going to go push to the right so that I have the calc highlighted, and I'll push enter on one variable, statistics, and this tells me that the mean of that data is 537.1 and the sample standard deviation is 20.701. So I'll copy those two numbers down. This is going to be that 537.1 minus this number here that we're testing. And we'll divide that by the sample standard deviation, so that's the 20.701 divided by the square root of the number of samples, and the number of samples was 10. So let's put this in the calculator and get, oh, sorry about that. I was writing things and not showing you what they said. So I'll put this in the calculator, and I have 537.1 minus 520 divided by 20.701. And I get 2.612. So the t-score of these data up here corresponds to 2.612. So we don't quite actually know where 2.612 falls on this line yet. We know that it's something above, so the mean is greater than 520, so we have a positive t-score. But I don't know if the 2.61 is going to fall here or here, because I don't yet know the value of the critical value of the test statistic. So we'll find that from the table. I'll come to my t-table and see that the critical value of the t for an alpha value of 0.05, and I know that this is probably not the easiest thing to read on your screen. So this here says t of 0.05. It might be hard to see on the video. And I'm going to follow that down to the number of degrees of freedom. And on this table, the number of degrees of freedom is n minus 1. So I'm going to go down to 9, and I see that 1.833 is the critical value of the test statistic that I need for an alpha value of 0.05. So 1.833 is right here, 1.833. So t-crit is this, and the actual value of my test statistic is 2.6, which will be the right of that, so it'll be somewhere over here. And so I will be allowed to reject my null hypothesis, because this test statistic, which is the number that corresponds to our mean of 537, is to the right of the critical value. So what I can write in my complete sentence is that at the 1% significance level, or sorry, not at the 1%, at the 5% significance level, there is significant evidence to support the claim that the mean time between failures is greater than 520 hours. Okay, so just to recap what we did here, our t-test is exactly the same as the z-test. The only difference is that we were not given the population standard deviation. Probably on the final, I'm unlikely to make you calculate the mean and standard deviation. I will probably give it to you, though you should expect that at some point I I ask you to calculate the mean and standard deviation of a data set at some point on the test. I probably just won't make you do it all in one problem. So using your calculator to put in a list and calculate the mean and standard deviation is something that I'd absolutely be prepared to do. Otherwise, you're stuck using the formula, which is a pretty long formula. And that's all I want to do for this video. I'm going to close this down, and I'll start up another video that's going to go through one more example with correlation coefficients and hypothesis testing with that. So.